Hi there everyone, welcome to the video lecture series on double integration using polar coordinates. Today we shall be solving the following question where we are asked to sketch the region of integration and convert the integral into the polar coordinates and evaluate the following question. Okay, let us see how to go about it. Here we see that the outer integral is from 0 to a, and here the inner integral is 0 to square root of a square minus x square, and the function over here given is x square y, and the order of integration is dy dx. Okay, so as we know now, since we are asked to convert it to polar coordinates and simplify this, so let us first write down the substitution that is required. So that is x equals to r cos theta and y is equals to r sin theta. That is the substitution we make as we had seen in our previous theory lecture. So from this substitution we know that this relationship comes up, that is r square equals to x square plus y square. Okay, now let us focus upon the limit over here, which is given in the innermost integral. We already now know that here the lower limit is y is equals to 0, which is the x-axis. Okay, so that is the x-axis, y equals to 0. Now let us see what happens with the upper limit. The upper limit is y equals to square root of a square minus x square. Now if I simplify it further, I get x square equals y square equals to a square minus x square, and then you get it x square plus y square equals to a square. Now from the above relation over here, if you call this 1 and if you call this as 2, you can see that r square is x square plus y square. Then you will have the relation r square equals to a square. Now remember, r is always positive, right? So when we take the positive square root, we will get r equals to a. Now this becomes the equation of the circle in the polar form, right? So this is one very important thing that we need to know, that the given equation which was there, y equals to square root of a square minus x square, we have now identified it as the equation of a circle in the Cartesian form, and then we have converted it to the equation of the circle in the polar form. So it's very important for us at this point. Okay. Now let us try to draw the entire region of integration and understand it. So here you have the x-axis and the y-axis. We are going to superimpose the graph of the polar coordinate over the Cartesian coordinate. So when we draw, we get r equals to a is a circle over here. Okay, and I have drawn the quarter of the circle. Now let us understand why this has happened. So first of all, if we see the Cartesian limits, here you can see that y equals to 0 is going uh, at the lower limit over here is y equals to 0, right? So that is the x-axis. So the region is bounded by the x-axis. Okay. Now, so let me draw this over here. When I draw x-axis, it's the entire x-axis taken into the picture. Now, if I see this limit y equals to square root of a square minus x square, we can see that it's going to be a semicircle, right, which is above the x-axis from minus a to a. We have seen this in our previous video lectures, and we have learned to identify the semicircles from the given equation. So we can see that it is the semicircle above the x-axis. Now the limit of x, which is x is going from x equals to 0 to x equal to a, this limits, which are the projection limit in the outermost integral, okay, pushes the entire region to be focused only in the first quadrant, that is This is the region we are supposed to shade. Okay, this is what has happened. X is going from 0 to a. Now let us see how to go about. So this kind of thing, instead of drawing the full circle, we have taken only the semicircle, and from the semicircle also we are taking only the quarter which is in the first quadrant. Okay, so this is what is very important. Now let us go further. So r equals to a is the circle over here. Dy dx changes to r dr d theta. Let us write down the integral in the polar form. The function that we have is x square by, okay, so x square will now be written as r square cos square theta because of the substitution x equals to r cos theta. So you just take the square and you get it r square cos square theta. Y is going to be written as r sine theta. Dy dx is r dr d theta. Alright. Now we have to write the limits. For the limits, we have to understand that for r, as in the previous theory lecture we had seen, that we need to draw a ray passing from the origin, okay, starting from the origin, and that cuts across the region or passes across the region. So here you can see it is cutting out the red boundary, which is the boundary of the circle, r equals to a. So the limits for radius are going to be r going from 0 to a. Now for theta, we need to sweep an arm in this way, right? Let's see again. For theta, we sweep an arm. Now we can see that the arm is being swept from 0 to 90 degrees. So the limits are going to be theta going from 0 to 90 degrees. Okay. Now let us simplify this integral into a more standard format. So the standard way of writing the integral is going to be this. Okay. Now I simplify this a bit more for our understanding, that this cos square theta sine theta can be written as sine 2 theta cos theta divided by 2. Now how do I get that? Let us see. So cos square theta can be written as cos theta times cos theta into sine theta, and I multiply and divide this by 2. Alright, so in the numerator I can see it is 2 cos theta sine theta, which is nothing but the first term is going to remain as cos theta. This entire bracket gets converted to sine 2 theta, right, divided by 2, and the other terms remain as they are. So that's how I simplify this term over here. Okay, now here I mark this star step a very important step, because at this step there are two methods available. Alright, I am going to discuss in this video the first basic method with the trigonometry functions which we are generally perform, and that method is slightly very basic, or you can call it very fundamental to the nature of solving, because trigonometry is very handy to most of the students. But if you are not comfortable with trigonometry, then method 2 can be adopted. It's slightly advanced, and a newer tool of mathematics can be used over there. So I'll be first discussing the basic fundamental method of trigonometry over here. So let us solve further. So considering the integral over here, this, we will go ahead. So here we have the integral. I is equals to integration 0 to pi by 2 up to yeah, 0 to pi by 2, and then the integration is from 0 to a r raised to 4 sine 2 theta cos theta divided by 2 dr d theta. Now, one very important thing again over here, if you observe, this entire function is in the form gr comma theta. Now this gr comma theta, it's quite multiplicative. What do I mean to say here is that I can write it as h of r times k of theta, meaning the r and theta are independent of each other. They are not intertwined into each other as a function. They are independent of each other. So the entire function gr comma theta can be written as a multiplicative function over here. Because this is multiplicative, what do I mean to say with this multiplicativeness? Let me explain here. See this r raised to 4 and sine 2 theta cos theta. They are separate. There is no relationship in between the two which is connecting. I don't have something like uh, theta sine theta plus r raised to theta or something. They are not intertwined into each other. That's what I want to say here. Okay, so this is what I mean when the functions are multiplicative in nature. So at this point, what we can do, we can separate sine 2 theta cos theta using this formula sine a cos b as half of sine a plus b plus sine a minus b. Okay, and I'll have this thing written. So remember, when you have the two functions in multiplicative format, what you can do is that while taking the integral of gr comma theta, alright, the double integral, this is over theta and this is over r, what you can do is you can separate this function and write this for k theta d theta, right, over the theta, and this one you can keep it for r, here as you have h of r dr over r. Okay, so that's what we have done. So I have taken r separately and theta separately. This integral has split up because of the function being multiplicative, and this is basically what Fubini theorem talks about. So we'll not go into detail about it right now. So solving of this integration we need to do. Now again, this step is very important because now comes the calculation part. When you integrate r raised to 4 upon 2, it will become the following expression: r raised to 5 over 10, and the integral limits are going from 0 to a. Okay, and this half is already there, and you have to get those terms there. So when you start integration over here, this half has come from the formula, and the half this was already there in the function has been shifted to the radius part. Okay, so now when you integrate it over here, you get all these expressions, and your final answer will be a raised to 5 divided by 15. Now what I would suggest here, if you are a BSc mathematics student or you are doing your graduation in mathematics, these steps which I am showing here, they are important for you for the calculation purpose. But if at your uh, graduation institution or in your institution, if the calculators are allowed, scientific calculator is allowed for you to calculate, you can skip this part. Okay, you can skip this easily. You can write the final answer directly from your calculator. Okay, because what is important is that you have understood the concept, and since you have come this far, it is believed that you are aware of how to perform the integration, and this whole thing of putting the values and using the fundamental theorem of calculus and etc etc is believed to be known to you. So this you could skip, and you can use the calculator if it is allowed at your institution. Now this is the final answer that we were going to arrive at: a to the power 5 and divided by 15. That's our final answer. Now let us see some practice questions for yourself. So these are the two practice questions that I would like to hand over to you. Whatever way we have done, the same way you can approach over here also, because here also in the denominator you can see x square plus y square is there. You can substitute it as r square and simplify it. You will get the following answer. The answer is pi by 2 times 1 minus 1 over square root of 1 plus a square, and for this one your answer will be pi by 4. Okay, so this was the question that I have dealt with, and any difficulty in understanding the following question, let me know in the comment section. Till then, keep solving good amount of mathematics. Thank you.